Imagine a world where the sun goes down and your only source of light is a foul-smelling lamp filled with whale oil. In the mid-1800s, that was reality. Whale oil was dangerously expensive, and the demand for it was driving several whale species to the brink of extinction. But then, history took a surprising turn. A Canadian geologist named Abraham Gesner figured out how to extract a clear, clean-burning liquid from coal and oil. He called it kerosene, from the Greek word keros, meaning wax. Practically overnight, this miracle liquid brought cheap light to the masses and quite literally saved the whales. But how exactly do we pull this liquid out of the earth? It turns out, making kerosene relies on a beautifully simple law of physics. Welcome to Simple Things Surprising Histories. Today, we're looking at a liquid that revolutionized the modern world. How exactly does thick, black crude oil turn into clean, bright-burning kerosene? To understand how kerosene is made, we have to start with its source, crude oil. Think of crude oil as a giant, chaotic soup of molecules called hydrocarbons, which are just chains of hydrogen and carbon atoms. Some of these chains are short and light, like the natural gas used to heat your stove. Others are incredibly long and heavy, like the thick asphalt we use to pave our roads. Kerosene sits right in the middle. It's the middle child of the hydrocarbon family, with chains usually containing between 10 and 16 carbon atoms. But when crude oil is pumped out of the ground, all of these molecules are mashed together in a thick, dark sludge. You can't just scoop the kerosene out. To get to it, we have to send the oil to a refinery and use a massive chemical skyscraper. This towering structure is called a fractional distillation column, and the way it works is essentially a high-tech version of a boiling kettle. First, the crude oil is blasted in a furnace to roughly 400 degrees Celsius. At this intense heat, the oil vaporizes into a gas and is fed into the bottom of the tall tower. As the hot vapor rises through the column, it starts to cool down, and here is where the magic happens. Different hydrocarbons turn back into liquid or condense at different temperatures. The heavy, thick stuff condenses quickly at the hot bottom, but the kerosene vapor keeps rising until it hits its sweet spot, a zone in the tower where the temperature is between 150 and 275 degrees Celsius. Right there, the vapor turns into a clear liquid, drips onto special metal trays, and is safely piped out. But the journey isn't quite over. The raw kerosene we just collected is full of impurities, especially sulfur. If you put it in a lamp right now, it would give off a terrible smell and create toxic smoke. To fix this, the kerosene is sent through a process called hydrotreating. It is mixed with hydrogen gas, heated, and squeezed under high pressure. This strips away the sulfur, leaving behind a liquid that is perfectly clear, highly stable, and incredibly energy-dense. In fact, it's so stable that we don't just use it in lanterns anymore. Today, highly refined kerosene is the primary ingredient in jet fuel. It can power a massive Boeing 777 through the sky without freezing at 35,000 feet. It's even used to fuel rockets headed to space. From a humble 19th century lamp that saved the whales to the roaring engines of modern aviation, kerosene has been a silent partner in human progress. It's just a simple liquid separated by heat, yet it completely transformed the way we light up the night and travel the globe. If you enjoyed this surprising history behind a simple thing, please hit the like button. It really helps the channel out. And don't forget to subscribe and turn on notifications so you never miss a story. Thanks for watching, and I'll see you in the next one.